Welcome viewer, and welcome to Lesson3. My name is Daniel Dongo from SOS Technical Training Institute, Buruburu. We are continuing on our series on fundamentals of electricity, and for today we are going to see how electricity can be, or how do we measure energy possessed by the flowing electrons. From our last topic, we discovered that electricity, or the way we transform electricity to other forms of energy, we refer to that as power. And we said power is a product of current and voltage. And we said that power is the rate of doing work. And we said work is expense of energy. And energy energy is what? Or energy is the ability to do work. So energy is the work, and work is expense or use of energy. So you find that work has the same units as energy. They have the same unit as energy, and the units are in joules. In joules. So, and it is always given by capital J. Capital J. So, in electrical to be specific, power and energy are related. In that power, we are saying this is the rate doing work. Power is the rate of doing work, and energy is the ability to do work. For us to get energy, energy is given by power times time. But time is always taken in seconds. Time is always taken in seconds. And all of us, or majority of us, are using electricity at home. And when you use energy, you are charged for it. The units that you are charged is known as kilowatt hour. And from our earlier explanation, it is possible to know what is what. Kilo simply stands for 1,000, and hour is time. But our time now has been converted from seconds to hours, so that you get 1 unit of electricity. You get 1 unit of electricity. So 1 unit of electricity is when you use 1,000 watts in 1 hour. When you consume that, then you have consumed 1 unit and you'll be charged for it. So, and all electrical equipment, all electrical appliances will have the rate of which they are working. So you get them rated in watts. And for example, for this heater that we are going to use, this heater has is rated at 1,500 watts. Rated at 1,500 watts. 220 watts. 220 volts. 1,500 watts. Meaning that if you use this heater for 1 hour, you'll have consumed more than a unit of electricity. You'll have consumed more than 1 unit of electricity, because this heater does work at a faster rate. It does at 1500 watts per second. So if you use it for 1 hour, then it means that it is 1500 times 1 hour, and you'll get 1500 watt hours. So if you divide by 1000, you get 1.5 kilowatt hour, which will translate to 1.5 units of electricity. So that's why you'll always hear someone complaining that they are using so much electricity. This is because most of the people don't care to note the rating of the equipment they are connecting to the supply, and they also not care about the hours they are connecting the equipment, because that's what will translate to the amount of energy used. Like now, this one, we will say that this is the amount of energy that has been used, and we have to know what this 1.5 kilowatt hour, what it does. Maybe it would have been it has been used for heating. For example, if we want to boil water in this jug, if we want to boil water in this jug, and we are using the same heater to heat the water, we would immerse the heater in here, connect it to the supply, and then time the amount of time that will take before the water boils. And by that, we will have calculated, and we can be able to ascertain the amount of energy that is needed to boil water, because that's what needs to, we must be aware of the amount of energy that we are using, because of course energy is expensive, and we need to use it like that. We want to demonstrate how electrical energy can be converted to heat energy by using this heater, a jug of water, and we also have our ammeter here. We want to see how much current is flowing, and then we see how much time it will take before the water boils. Of course, the water temperature is around 20 degrees, but we'll raise the temperature to 100 degrees, and you'll see how much time we need, and you'll also be able to see whether we can get to calculate the amount of energy that has been used. And we start. Put the jug, plug the equipment to the socket, and check the amount of current that is flowing. Plus, we also start our timer. Now, we want to find out how much energy that will be used to boil this water from around 20 degrees to 100 degrees, and we also check the time that we shall use. So we connect our heater to the supply and start timing, and we see the amount of current that is being drawn from the supply. It's come to around 5.3 amperes, and you see how much time it will take to boil the water. We have already seen the amount of current, so we can remove our ammeter and concentrate on the time that's going to take. You can see already the water is starting to produce some bubbles as it heats. What is actually happening on the heater is that the current flowing on the heater is getting some resistance from the heater coil, and because of the collision that we said that I is given by V over R, and because of this resistance, this is what is enabling us to get heat, and we want to see how much energy we'll use to convert water. Our water is about 1.8 liters at 20 degrees, and we want to raise this to maybe 100 degrees. We want to see how much time. The time that we have used now goes to around 2 minutes. It's around 2 minutes. It's quite hot. And then we'll be able to see if you want to boil maybe a bigger amount of water, how much energy and how much it would cost you to do that, because we have said that electricity is a form of energy, and of course all forms of energy translate to some cost, and you see whether it is viable option or not. Time taken is now 3 minutes. We are doing 3 minutes. See, from our from what we had seen earlier, we had seen that our ammeter was. Can we check again so that when we are doing our calculation, we can be more accurate? So the current is 5.33 amperes. Doing 4 minutes, 5 minutes. No, 6 minutes. I think the water is boiling now. So 6 minutes. We have done 6 minutes. So when we come and try to assess the amount of energy that has been used, you see that power is equal to of which from our measurement we're able to take the measurement for I, and you get 55.33 amperes. Our voltage was and it still remains 240. So we can, from that, we can be able to calculate the amount of power that our heater is developing, and it means that we multiply 240 times 5.33, and we get $240 times, I have to clear this, 240 times 5.33, get 1279. So the result is 1279 watts. So okay, we have seen that this is the rating of our heater, and this is the time it has taken. So we multiply our power times time, so that we get the amount of energy that we have used. Now we have used 6 minutes, and we are supposed to use hours. So you divide by 1,000, and we get that it is 1279 times 0.1 hours, and we get coming to 12 becomes to 127.9 watt hour. So now we are supposed to divide this by 1,000. Divide that by 1,000, and we get that we have spent 0.1279 kilowatt hour. So this is the amount of energy that will be charged for boiling this 1.8 liters from 20 degrees to 100 to probably 100 degrees. It means that we have used 0.1279 kilowatt hour. So this is what will be charged. Viewer, we have come to the end of our lesson. Your presenter was Daniel Ndungu, and stay tuned.